Hello and welcome to my channel. I am n+1 Augustine. In this lesson, we are going to show that the series summation n equal to 0 up to infinity 1 divided by into bracket n+1 times into bracket n+2 converges and find its sum. Now, we know that a series is convergent if its sequence of partial sum converges. So, if we represent the sequence of partial sum by Sn, that S sub n equals summation from n equals 0 up to n into bracket 1 divides n+1 into bracket times n+2 into bracket. Wow, this is very nice. Let's see. So we break this to partial fraction form. So we have 1 on I plus 1 times I plus 2. I'm breaking it to its partial sum. That's why I use I to represent n. Now, this one, you can use the partial fraction decomposition method. Wow. Where these factors are linear. So we take a over I plus 1 plus b over I plus 2. And then we look for the constants a and b. But I'm going to use intuition, right? Okay, I have I plus 2 here. So I take I plus 2. If I subtract 1 from this, I'll get the 1 here. And if I subtract I from this I from this I will give me 0. 1 from this to give me this 1. Wow. So, all divided by I plus 1 times I plus 2. So, this gives I plus 2 minus 1 plus I. All divided by I plus 1 times I plus 2. Nice. So here we write I plus 2 divided by I plus 1 times I plus 2 minus I plus 1 divided by I plus 1 times I plus 2. Wow. So you can see that I plus 2 will cancel I plus 2, and we have 1 divided by I plus 1 minus I plus 1 will cancel I plus 1. We have 1 divided by I plus 2. So this is the partial fraction decomposition of this one. Now, here it means that our Sn is now equal to summation from I equal to 0 up to n of 1 divided by I plus 1 minus 1 divided by I plus 2 in a very simple way. So, let us find some values of I, putting in 0, 1, 2, 3, 4 going. If we do that, we are going to get, if we take 0 plus 1 is 1. So we are going to have 1 minus 1 out of 2. Plus, because we are summing from 0 going. So if you put in 0, you get this. Plus, we put in 1. 1 plus 1, 2. 1 out of 2 minus 1 out of 3. That is 1 plus 2 is 3. Plus, if we put in 2, 2 plus 1 is 3. And then 2 plus 2 is 4. Plus, dot, dot, dot. Wow, up to what? Now, you see that each of the terms that we are putting inside, you see that if n equal to 0, the next term will be n plus 1. That is 0 plus 1. That will give us 1. The other term is n plus 1 plus 1. You see that we have n plus 2. Right? Yes. For n is equal to 0. So the next term, we add 1 to 0 to get our 1. You add 1 to 1. So look at this. 0 plus 1, 0. 0 plus 1 plus 1 is 2. Wow. So here, if we take n, we have 1 divided by n minus 1 divided by n plus 1 plus the next term we add 1 to this. That will be 1 divided by n plus 1 minus 1 divided by n plus 2 in a very simple way. I hope you've understood this part for me. The first term is 0. The second one will be 0 plus 1. The other one will be 0 plus 1 plus 1. Wow. So if this is our n, 0, 0 equal to n, then n plus 1 will give us 1 because 0 plus 1 is 1. N plus 2 will give us 2. That is 0 plus 1 plus 1. So if we want to find the next term, that's what we do in a very simple way. So if here is n, then the next one will be n plus 1. And it goes like that in a very simple way. I hope you've understood this part very well. Now, here, this is our Sn. Because we've summed the sequence of partial sums. So here, negative half cancels positive half. Negative 1/3 cancels positive 1/3. Negative 1/4 will cancel positive 1/4. Then negative 1 out of n will cancel positive 1 out of n. Then negative 1 out of n plus 1 will cancel positive 1 out of n plus 1. So you will see that all the terms, but the first term and the last term do not cancel out. All the terms, but the first term and the last term do not cancel out. And we say that the terms telescope to 1 minus 1 divided by n plus 2. That is the sum, rather. The sum telescopes to 1 minus 1 divided by n plus 2. That is why we call this one a telescoping series. So now, this is our Sn. We are going to find our Sn, the limit. So we take the limit as n approaches infinity. 1 minus 1 on n plus 2. So, let's see. For this, we take the limit of this. The limit as n approaches infinity of 1 minus the limit as n approaches infinity of 1 divided by n plus 2. So here, the limit of a constant is a constant, so here is 1. Minus this one, we have 1 divided by n divided by n divided by n plus 2 divided by n. So we have 1 minus the limit as n approaches infinity. As n approaches infinity, that is, as n becomes a large number, 1 divided by a very large number will be 0. N divided by n is 1. And 2 divided by a very large number is also 0. So 0 divided by 1 plus 0 is 0. So here we are going to have 1. So the sequence of partial sums is convergent. Hence the series is convergent and its sum is positive 1. Thank you for watching. Please like, share, subscribe, and leave your comments.